the Raku solutions of this week's Perl Weekly challenge, actually, Raku challenge. So go to challenges number 69. There are two tasks. The first task is to find all Strobogrammatic numbers. The number is a number that looks the same when looked at upside down. Well, actually, when you rotate it 180 degrees, it should be more or less the same. You are given two positive numbers a and b, such as a more than or equals 1, less than b, and b is actually any number. Write a script to print all Strobogrammatic numbers between the given two numbers, like 69, 88, 96. Actually, it's not said whether 1 or 0 match this condition. Actually, 0 definitely matches this. 1 potentially yes, but let's look at what people have there. So recap, go to Raku solution directly, Perl solution, and now it's Raku solution. Okay, my solution, yeah, let me postpone it to the... And I will start with this RNA Sommer solution. So what's there? So yeah, first of all, let's see. So first of all, there's, you see, so it's unit sub main. So which means that the whole program is a single unit, so we don't have to add curly braces around the function. So main, there are a few parameters like a and b, and there are also where clauses, so you can limit the input values. For b, it's even more complex, and there are a couple of other keys. Calculate mode, I don't know what that is yet, but and minus v. Okay, so the calculator. So first there are some digits, the definition of valid numbers, and if you are in the calculator mode, then what's the so see, so then you are allowed to have 2 and a 5 in the output. So it means that if you rotate the number 2, it looks like 5, especially it's if it's displayed on the calculator display. Okay, that's fine. That's great, actually. And the function is Strobogrammatic integer number. Unless all number come. What is a number? Number, we split it into digits and see if all of them, that's a bit weird, but okay, equals any of, oh my god, Strobo key. So these are 0, 1, 2, 6, 8, and 9. So it's false if these two things are not equal. So basically, it looks like if we see something else which is not here in the keys, then we know directly that this is not the number. Okay, then yeah, flip upside down, well, actually rotate, then split into characters, and then yeah, we'll basically make a string replacement, what the Perl tr function is doing, and then we join it together. If it's the debug mode, we print it, and finally we make another. We'll test if the numbers are equal, the initial number and the final number strobo. Then the range from A to B, we grab something, then we join it by comma and print it. What this is. So basically there's the function is Strobogrammatic, right? But this is a function which takes a number, and we're trying to call it on something, basically on the number from this range. And this thing, yeah, actually I never met this before. This is called method operator, and basically it's syntax sugar, so that you have a function like this, and you can use this function as a method, and you can call it on something. Basically this something is number. Oh my god, yeah, okay, but I suggest we can do something. So for example, my function of my argument, just print it, right? And for example, you can call this on my function like this or like that. Test Raku challenges, save it to test. Method op Raku, run it. Where am I? Yes, so see, so we can call a method on a number. Actually, of course, it can be a string. There's no difference. I mean, really a string. And the function will be called. Cool. I didn't know about that. Actually, I never used it. Okay, so let's go to say Perl Weekly Challenge Club, challenge number 69. Arla CD Raku ls Raku ch. Where's the number? Is it string? ch1 Raku. Right, AB, let's say from 1 to 200. Right, so all these numbers, and let's see, calculator. Yeah, 59 is there, and 25 as well. Nice, really interesting solution. Okay, let's look at the another solution. Begin comment. Okay, so you see, so Raku, the Raku language is not recognized by GitHub, which is really awful. I mean, the fact that it's not recognized, not the solution. I don't get anything about the solution, but let's see. So what's there inside? So yeah, so here is some information, the definition. Okay, so my unsigned int. Wow, is it Raku? It looks like. So this function main, that's a really interesting style of coding. So bound, this is not a smile. This D is not a smile. It means that the value should be defined. Low bound, which is bound. What is a bound? Bound and subset of unsigned integer, where the number is between 1 and max, while max is this number. Right? Okay, then another bound and another restriction. Finally, the main. So we print something when then we ask to enter something, the numbers basically. Output. Okay, if what this means, wow. So if, okay, let's just run it. Athanasius challenge 69 Raku ch1. Okay, so it doesn't ask to enter anything because it asks us to do this. Yeah, of course, yeah, it's, yeah, okay, so it's just echoing, so it's from 1 to 200. Right, challenge task. Okay, so this is what we see. Input, yes. So how does it work? So this is where we finish the output. If this is less than b, what is that? So it's number, the first Strobogrammatic number. Okay, so there's a function to find the first number, which is obviously bigger or equals to. So the first Strobogrammatic number, again, unsigned integer, defined minimum. And this is the return type of the function, which is also defined and is unsigned integer. Mean characters, number of characters in the lower boundary. Number of characters first. So if it's 1, then we return 1. So if there's only one character. If there are more characters, then we do something. 1 0. So we repeat this 0 this number of times. So we get number where the first digit is 1. Actually, the string which represents the number with the first digit 1, then some zeros, and then 1 in the end. And the first Strobogrammatic number is... okay, this is the first. Why is this the first number? So so it's I saw this as size divided by 2, but actually it's size less than 2. So basically, if the size is 2, this is 0, there's no, so the first number is 11. If this is 3, then it's 101, right? Okay, so the next, and we are trying to find the next while we're still within this boundary. Well, first is less than, and if it's okay, next, we get some digits. Skip empty. Nice. That's again a really nice thing, because what it does actually, okay, split comb Raku. So here, so the common problem, if for example I have a string and I want, actually, yeah, this is better, and I want to have separate characters of this string, I cannot do it like this. Split, say, or actually even DD. Let's see what it does. Raku split. Oh my god, no, let's go. Raku challenges test Raku split. So you see there are 2 empty strings before and after the actual string. And if, for example, I will do it like this, actually I've never done it as well, I believe skip empty, so it will skip empty elements, right? Number, there's no number. Yes, wow, nice. But actually what you can do is just to do it like this, right? So it's exactly the same, so it's less characters. But nevertheless, let's go back to the solution. So we skip, then we transform this to create an integer. So basically this was the number, it's set here. Then it became the string. We treat it as a string. Then we have separate characters, and actually each character is a digit, and we convert it back to a number, to an unsigned number. Then it's the size, the medium, the middle of this. This is actually what I saw earlier instead of this. And then return middle. What is middle? The middle, there was some definition. Basically, middle is, so yeah, so there are a few definitions. Middle, which is the conversion from 0 to 1, 1 to 8, 8 to nothing. Okay. Outer, 1 to 6, 6 to 8, 8 to 9, 9 to nothing. Some inner, 0 to 1. And there are some pairs. Actually, within pairs, there are all the digits that you can rotate upside down, and you will see the same number. Well, except 2 and 5, yeah, but that's not required in the task. Okay, so it's middle, return middle digits, the first digits, or 11 if the size is 1. If size is, what is it, odd, right? Then, yeah, there's a comment, odd. If defined, if there is, basically, if there is the number which is middle, which is actually one of these. I find the solution really difficult. Then, like, take next, return, join all those digits. Basically, here you will have some number, and you will return from this function, and you will find the next number, right? But that's not the end of the function. But okay, so for example, we find the next number here, and then we return it here, right? And inside this block, we print the number, and next number is next number, and until this, or while this number is less than b, the upper boundary, then we again trying to find the next number and print it with a comma before it. Okay, fine. And this is inside the next strobogrammatic number routine, subroutine. This is the part which we never looked at yet. Oh wow, also interesting. So actually I also didn't know that. Well, I didn't use this thing. So in the loop variable you also can specify the type. Really interesting. Something like this, but inside the loop. Okay, we're doing something. If now we are looking at the outer, so we see in the first thing it's the middle, then it's inner. I cannot understand this, but here it works. This is the first digit, this is the last digit in this array. We make it 0 and 1 for some reason. On shift, then join together, and yeah, and the usage function. The usage function is called automatically when you don't have any arguments, if I'm correct, right? Like this. Yes, this is what it usage. yeah. So we're printing the something from this usage, basically taking the global variable usage. Wow, interesting. So basically usage Raku. Can we just say usage? I've never used this function again as well. So Raku usage not found. What if we have a submain? Right. Or is it? Nice, interesting. Wow. So it's the generated string which Raku builds based on your function. Okay, let's go to the next solution. Next solution by Colin Crane, Raku number 1. Raku number 1. Again, the main function, but this time, unlike RNS solution, there's the real function, not a unit. Some limits, some defaults, which is really nice. The order, number of up to blah blah are generated. So what is it? So number of characters divided by 2 and number up to 10 powered by a is it logarithm or what? Yeah, logarithm through characters. List the accepted digits. Center, again this terminology I don't quite understand. Then so these numbers are not changed after being rotated. These numbers will be changed, actually these two, right? 6 and 9. List. So list, what is list? So we take remove leading 0. Thanks Liz. Remove leading 0. So what that is, so let's copy this thing to my test file, and what it does, the tail Raku, for example. So list tail, so this one, oh, was it? Yeah, no, one tail. Now we remove the last digit. So tail. What is it? What is this argument of the tail method? Tail, fail, tail. Supply integer creates a tail supply with the same semantic as list tail. Good. What does this list tail mean? What does it do? Returns a sequence contains the last n items of the list. Yeah, this is what I thought. So it contains the last -1 item. Counting from this side, I believe, right? Okay. Okay. So we removed leading 0. What is leading 0? What is this? Remove the leading 0. Why should we remove the leading 0 from the list if we just define it here as a constant? Stereo center, just a synonym, and choose trivial single digit cases. For order, this is really nice construction. So it's basically for the loop from 0 to the order. What is the order? What is the order? Hey, where is it defined? Ah, yes. Okay, so yeah, but not the last number is one less than this order. My events is empty. Empty? Is this something that exists in Raku? Empty constant. Wow. Class sleep. Really interesting class. You've never heard about this, I believe. Empty is a sleep of the empty list. Yes. Sleep of the empty list. Blah blah. Sleep then list. Okay. Both are empty. Reset holding arrays. Phone number. So we iterate over the numbers, over these, right? Which is the left digit. My right digit is left transpose, transform. What is it? What was it? Transpose or transform? TR and Perl. What is it? Hey, I want to find it. Yes, routine transform, transpose. Hey, transpose. The first one will transpose. Okay, so it means transpose. Transpose is this and then flips. Basically, it's a reverse of the string. And we just push this to the result. Events, right? Events. It's not events. Yeah, it's events. And then for center is these numbers. I don't understand why we have to split list and center. Then we do something like this. Join using the center number. Okay. And then we append it to stereo. What is stereo? This is the empty array, if I'm correct, right? Reset holding arrays. It is not digit to the working list. This function, this construct is a reduction meta operator with a cross operator for concatenating. So basically, it concatenates elements from these arrays, right? And then last. And if these conditions are passed, then we print the number from this array. Okay, I didn't understand how it works. Calling crane. Go here, cd. Calling crane Raku, right? Raku. Oh, it's called Perl 6. Wow. Chading P6 and actually DDC. So first of all, that's here, and in the previous solution there was V6. What was the previous solution? Let's see. Here it was V6C, I believe, right? Oh, V6D. Nice. Okay, right. Whoop. Yes. Okay, so it works. Yeah, interesting. I don't know. I don't understand how it works. There's no number 1. Of course, there's no number 1 because it's not here. There's number 1 is here. Yes. Okay, let's go next. Next, Javier. Look, wait, I'm not sure I know how to read this. Sorry, really sorry. But let's look at the Raku code, which I know how to read it. Okay, but again, Perl 6 and P6 extension. But let's go to Javier Raku 16 to 200. Right. So there are commas here, which is really nice. So okay, so again, so this is what we've seen a few times. Answers. This is the array to collect the correct numbers. For this range, original number, we are converted to 3. Actually, it's so we have this I, like the Polish notation I stands for integer, but here we have string. Actually, I don't understand why we need a separate conversion to string, but nevertheless, check and remove 6, 9 on all these pairs, 8 pairs, and remove. So search length, half of the length of the string. Loop. Wow. I don't know if I ever used loop in my real code. But it's basically like C++ or 4 in Perl. I think we can just make the for loop from 0 to search length with the hat character before the search length. Substring before, substring after this position. If the first it's like 2 characters just on the left and on the right next to this position. If the 6 and the second one is 9 and all the rest, so if all these conditions, if one of these condition is okay, then we do substring from the beginning, well, to somewhere, I carries -2 to the end of this. So basically we're not taking the first and the last, right? Wow. J++, J minus, and wow, and also we decrease the length, else last. So if nothing like this is found, then we can break the loop, which means that we can reject the number. And if everything is okay, and if there is a number, then we can push it there, and then we can print it. And this join. Nice. Extra space. Okay. Right. The next solution by Loren Rosenfield. Look at this. Wow, that's cool. So first of all, this. Yeah, so Loren's solution is really good. So the sub main with integers, the boundaries. You see, so there's the chain here, really nice. For the range, and we skip this number if it doesn't match this regular expression. It doesn't contain the number 1, digit 1, but that's fine. And we print this number as this number is the same as flipped and trr, the big trr. By the way, this tr is this like the alternative. So what's the difference between these two? What's the difference between these two? Where is it? In replace non. Yeah. Wow. In place transliteration. So it's transliteration. It's not transpose. So it's a non-destructive transliteration. Non-destructive. So we replace this and return the new string. Actually, I forgot about this. Okay. So let's go to cd back low Raku. Why is it still P6 in the extension? 200. Yes, and if we'll add 1, we'll have a bit more. So actually, notice this minus, so it's a negative character class. Okay, that's simple and it's impressive. Then Mohammed, should we leave my height for the end. Let's keep it for now. Just don't forget about this solution. So this is solution by Roger Bell West. So it uses a test model, so we test it directly. So it tests the numbers from 50 to 100. It should be these. And the function Strobogrammatic numbers. Okay, so yeah, the code style is different again. So it's two spaces indentation, no spaces after commas. But okay, so the digits, again, no one. Then the regular expression, or regex, digits joins the keys vertical, and we create the regular expression as a string, which we later use here if, so yeah, so we skip the number as we just saw in the previous solution. If there is 0 at the end, we can skip it again, because we cannot have 0 in the beginning of the string, obviously. Then, what is it? NL. It's a new line. Definitely it's not. It's some numbers, so it's the length -1. Locks. Blop. So we fill this hash with obviously translated digits, rotated digits. Then the second variable, which we will decrement for some reason. So I believe we are, yeah, so we are just looking at this number and compare it to its potential upside down version. And if there are some still numbers there, we take this number, right? Okay, let's try to run this. Roger, Raku, 1, 1. Okay, so yeah, this test passed. Then Ulrich Rike. The solution is, again, no syntax highlighting from the GitHub side. Uses v6, but the extension is Raku. Function, so function main AB. If it's incorrect, prints a message. If it's correct, then we just grab this with this function. Now this time we're using it as a function, not like we did it here. So yeah, so this is a function call, and it returns Boolean value. The pairs. Wow. Yeah, so we didn't see these before in other solutions, so we are now taking the number and create a string by calling this, by using, but by applying this field operator length. That's obvious why these spaces. Then we go, so yeah, we can, in Raku we can just add the hat character instead of this, and we don't need 0, but it's not that important. If there is this number, which number? If, so we just take this one character, translate this, and if it's there in the hash, we continue. If not, we just break this loop, and we break the function and return false. Downside it, so it's upside down number, obviously number, flip, comp, so we split it into characters, transform it again, so we make these transformations twice for the numbers that pass this filter, join, and compare with the initial number as a string. Okay, so it's kind of extra variable, right? Yeah, Ulrike Raku G1 to 200. Right, it works. There's no number 1 here, right? Digit 1 here. Okay. Final. That's it. So what is left? So it's Raku and Perl. So it's my solution again in the end. Raku solution, pure Raku solution. Luca Ferrari. Oh my god. So it's Luca Ferrari. Wow, let's make this smaller. Nice. Why these? So 2 numbers in the signature. That's right, working from A to B. Let's maybe run it immediately. Luca Ferrari, Raku, Chiwan, Raku. Oh, wow. 200. Where's 69? There's no 69. There is no 69. I found a mistake. I hope. Okay, so nevertheless, so it's using the gather and somewhere there's take. So the gather take pair, really interesting thing in Raku, and we just put them in the array in the end. So there's more than one take. That's the thing that makes this even more powerful. Special case, single number. So yeah, definitely if it's single number, and if it's 108, it cannot be 6 or 9, right? Yeah. Then we just take this number, then we split. Okay, so we've seen this solution with skip empty, just without these parentheses. Special case is number of digits is odd. The central digit must be self-reversing. Okay, so this is the central digit. So yeah, now. But still, I don't understand why we need... so the central number in one of the previous solutions, we saw this central separate hash with central numbers. Basically, yeah, the central number cannot be 6 or 9. This is now... now I understand this. Check in the label until this is okay, and last if this is not okay. Scan over the digits of the indices of these numbers, left, right. So what this is, so left, these are indices again, index, and the index if we count from the end of the string. Last if we met the middle, then okay is false. Okay is false. We can just actually skip the break loop here, right? If it doesn't exist in the table, or if the other character doesn't exist there. Okay, so yeah, we checked the left and the right character, actually character associate. So we're using an index here and then the index here just to take the character, because the loop is the loop variable is index, not the character itself. And the final check, ampersand equals. Yeah, so we just add like to the previous solution. We can kill it or we can continue if the digit... What is this reverse? Oh yeah. I thought we already checked this here, but here we only checked the existence, and here we check if the digits are, like if the key corresponds to the value. Okay, yeah, and found unique, join unique. I wonder if so it's like 69 and 96 will be merged to a single number, but for some reason 69 is not in the result. Next, Mark Anderson, solution number 1. Yeah, that's nice. That's basically the same as wow, is it the same or basically the same as let's open this one, and was that Loren, right? Raku 1. Yeah, so here we see this transliteration, and here we're just using this trans, right? 69, 96, because we don't need to transliterate 0, 1, and 8, and the boundaries. Nice solution by Mark Anderson. Mark. Hey! There are 2, 3 marks. Mark Anderson, Raku. Yeah, 69 is here. Okay, what else? It was Mark Anderson and Shahid Noshmand, Raku 1. Yeah, basically again the same solution. I like to run this one. Shahid Raku number 1. What is R? What is A? What is B? I wonder. Can I pass this like this? Obviously not. But yeah, we see that there, like, we can take this one. We can do like this. My A is 2. My B is 200. Bloop. Yeah, so it works. Nice. And there are 2 solutions left, if I'm correct. So it's oh, Mohammed gave. Actually, it's 1 solution. Yeah, there are too many links, but the solution is only 1. Okay, so it begins with some defaults. That's good. Here we can use B more than A. If Strobogrammatic numbers, yeah, I really like that we can use dashes in identifiers in Raku. Then we just join it with a comma and print it. So the function start, stop if the boundaries are incorrect. So again, there's no 1, there's no 0. Let's see if that works. So basically like numbers 101, yeah, or 808 or 609 should be there in the output. So empty, we don't need this one actually. It will be empty. Next, if n less than 10. What that means? Start, stop. Next, if n less than 10. So stop should be less than 10. Brrr, I didn't send that. No, wait. So we skip the first numbers which are shorter than 2 digits, right? Okay, so found for the character, so I is a character. Again, like the Polish notation, it's int, but it's character, right? If this digit exists in here, these are also not really required. Then we add it to the match array. Okay. If not, we just break this, and found is only set to true if we didn't reach this one. Then we can add the number, which is the collected digits joined together and flipped. I wonder where we check if the number equals to its reverse version. Yeah, it's here. Join, flip. Right, and where's the translation? The translation happens here. Okay, so it's Mohammed. Raku 1 Raku 69. I wonder if really like it's number 101 appears there. Oh, how do you work with this? Like this? Number 101 didn't appear here, right? And actually, okay, so if 101 is incorrect, but 808 should be there. And finally, my solution. In the end, where is my solution? It's here, Raku solution. So this is my solution. So yeah, I don't like to add this main function just because it's a small program. Right, and I will just put. What's the difference between put and say? The difference here is that with put we don't have these parentheses here on this output. And I'm just grabbing from the range, and the grep function has 2 parts. If the number contains the allowed digits, and if its flipped version is the same as the original number. So again, we don't have to translate 0, 1, and 8. And I think that's it. That's all from this week's. Yeah, I didn't run mine. Oh wow. Ash Raku 1 Raku. Yes. So yeah, the output is not like it was requested in the task, but please excuse me. And I think that's it. So this is task number 1 from the week 69 from the Perl Weekly challenges, and it was only solutions. Were only solutions in the Raku programming language. See you next time. Goodbye.